Okay. Shall we start?
Okay. So hello everyone. We are coming from data science section A01, group number 3. Now we will talk about experiment on student stress analysis with one-way repeated ANOVA method. Okay, on the next class. This is our team. Our team from three people. I am Kitanayam Green. And
Okay. And Kasuan.
And the Tawi.
Oh. Okay. So let's talk about the abstract. The abstract. This experiment focused on studying the data analysis process using one-way repeated ANOVA with datasets of student state level compared across different semesters. The aim is to test the hypothesis that as the semester progresses, the stress levels of students will differ from previous semester. This analysis will help us understand the change in stress level over time and can be used to develop strategies to help reduce student stress in the future. On the next slide. The overview, we will talk about the introduction, methodology, dataset overview, data distribution, correlation, trend analysis, stress and grade comparison, one-way repeated ANOVA, hypothesis, and conclusion. On the next slide. The introduction. Nowadays, all students face academic challenges, which are crucial factors in determining their future. As a result, some students experience accumulate stress over each semester. To study effective methods for reducing stress, we have formulated a hypothesis that focus on analyzing student stress level across different semesters using one-way repeated ANOVA and find insights that can inform interventions to reduce stress from the student and improve overall academic outcome. Okay, on the next slide. On methodology, first we preparing the data and then we use that data to find the insight from descriptive analysis. And then we will create a hypothesis and analyze it. And finally, we will summarize the data by combining two analyses together. On the next slide. So the dataset overview. We use the sample of 20 students across the 4 semesters with key variables including stress level, age, study hour, exercise hour, attendance, and grade. And yes, we will talk about the distribution.
I will explain about the data with distribution. In this distribution, this data shows this graph shows the stress level of the student distribution. This graph shows the distribution of the stress level among the group of students. Most of the students the x-axis shows the stress level of each student, and y-axis the amount of students that occurred in each stress level. In this graph show, most of the students have stress level around 6 and 7. The next slide. And this graph shows the grade of the student in each grade of the student for each of the grade of the student for group of group. This distribution describe the grade of a group of students. And the x-axis show the grade of the student, and y-axis show the number of students that have in each grade. According to our grade, most of the students get grade point in 3, and this show most of the students have in every grade level. And the next slide, the distribution show the exercise hour in the group of students. This graph shows the binomial, the bimodal shape. So we have two peaks. Most of the students are exercise in 2 hours or 2.3 hours, 2.3 or 2.5 to 2.3 hours across. And the next slide. In this graph show the study hour of the group of students. The x-axis show the study hour, and the y-axis show the amount of students in each study hour. In according to the graph, most of the students spend around 12 to 40 hours in their study life. And the next slide show the attendance of the student assembled or group. Most x-axis show the attendance, and the y-axis show the amount of students who attend the class. And most of the students get 8 to 85. Most of the students get attendance score with 85. And the next slide show the distribution of the age graph. In this age graph, the x-axis show the age of the student, and the y-axis show the amount of students at each age group. Most students have around 21 to 23 years old. According to our data set and distribution, students have around 21 to 23 years old, and most of students attend 85. Most of the students have the score in attendance 85%. So most students have a great score in attend and exercise hour gap in 2 peak like this. And the next slide. The next slide about the correlation, Bank will explain.
Okay, so on this method, we use correlation coefficient method that is one of the statistical measuring method that can find the relation between two variables in the dataset. So on the image on the right side, it shows the formula of the correlation coefficient, and it shows in the symbol of alphabet. Is the result of the summation of the value of x minus by the mean of x variable, which x is variable number 1, and multiply by value of y minus by mean of y variable, which is the variable number 2. And then we will divide it by the root of the sum of the square division for x multiplied by the sum of the square division for y. And as the result, the number is ranged from -1 to +1. When correlation coefficient is close to 0, it means that there is a weak relation between variables. And when correlation coefficient is close to either +1 or -1, it means that there is a strong relation between variables. So on the next slide, it will show the result of the correlation coefficient for every variable in this data. We use the Python to calculate it and create a chart. From the state level column, we see that there are three negative correlations, which are attendance, exercise hour, study hours. It means that when students attend more class, exercise in too many hours, or study too many hours, their stress level will slightly decrease. On the next one is there are two correlations which is positive and negative. We will look at the negative first. On the negative side, the study hour and age show the weak relation, which can mean that when the student age more, the study hour will decrease. On the positive side, the exercise hour and grade show the weak relations between age. So it means that when student age gets more, their exercise time and their grade will increase too. On the next one, the study hour, it shows the strong relation on attendance and exercise hour. So it means that when students study more, their attendance score and exercise hour will significantly increase. But their grade and study hour show moderate relation, so their grade is slightly increased. On the next one, exercise hour, they show the strong relation on attendance and moderate relation on grade. So it means that when they do exercise more, their grade and their attendance will increase more too. Finally, on the attendance, they show the moderate of relation with grade. So it means that when the student attend more class, their grade will increase too. So on the next slide, I summarize it in each category. So on the next slide, is the yes. Okay, the next slide it show the summary of the correlation that show in the chart and the summarize it in the text, so we can look and understand easier than the chart. So it shows the distribute from negative and positive in each variable, and from the data we can summarize in the next slide. So we can summarize that we can encourage the student to study more and do the exercise in the free time, which can help managing the stress and the student academic performance furthermore in the future. So on the next slide, we will see the distribution of the trend analysis. On the trend analysis, the chart shows the relation from the state level across semester. So the graph will track how each student state level change over 4 semesters and help compare how the state level vary from different semesters. Each student has a unique trend, right? Some students' stress level increase over time, while some students also decrease over time too. The others have the fluctuated stress level across the chart. On the next slide, uh, on the next slide, we will see that the stress and grade comparison chart, it shows the average stress level and grade for each student. So the blue bars is the average stress level. The pink line is the average grade. From the chart, you will see that some students have high stress and high grades, but some are also low grade. So grade may be vary regardless of the stress level. So on the next slide, the impact on stress level. There are two charts that we show in the slide. It is the impact of study hour on stress level and the impact of exercise hour on stress level that different from each semester, range from 1 to 4. On the study hour, the effect of study hour on stress level is inconsistent and vary by semester, and exercise hour is more exercise generally lead to lower stress and consistency across all semesters, which can be helpful for teachers to acknowledge some students who have a hard time to deal with the stress level. So this chart can helping teacher fixing that problem. So on the next slide.
Okay, I will be explaining for one-way repeated ANOVA on our hypothesis testing. So what is one-way repeated ANOVA? It's a model for the analysis of variance between the means of the groups. In terms of groups, we mean we are tested under the same subjects under different times or different conditions. In our case, it is one way, so we can only need to consider one different time or different condition over only one variable. And the right side is the written formula. For our hypothesis, we have our objective, which is to determine the student stress level, which will be either significantly different over semester or not. So we have two hypotheses. One is null hypothesis, and we call H0. And in this hypothesis, stress level are approximately equal over all semesters. And another thing is alternative hypothesis, which is at least one of the semester has a significantly different in stress level. And as we have calculated with ANOVA, we have these results. F value becomes 0.7917. After that, we have numerator degrees of freedom, which is degree of freedom between groups, which is k minus 1. So we have 4 groups, which is semester 1, 2, 3, 4. So 4 minus 1 is 3. And another one is denominator degrees of freedom, which is the degree of freedom within the group. How we calculate is k is the number of group, right? K minus 1 multiplied by n minus 1, which is n is 20 sample, in our case 20 students. So 20 minus 1 into 4 minus 1 is equal to 57. And after that, we calculated that p value is 0.5036. So based on our p value is greater than 0.05, which is a significant value. So we fail to reject the null hypothesis. We can say there is no significant difference in stress level between the semester. So we can say that student stress level does not significantly change between the semesters. And as we explained in graphs, here is our pulse plot. And in this pulse plot, the pulse here are the mid 50% of the stress level of each semester. And this line is the median for each semester. And these whiskers are the upper bound and lower bound of the pulse plot. And as we can see, semester 4 has a wide range and semester 2 has a smaller range in terms of stress level, which means in semester 4, students have various stress level, and in semester 2, most of them are feeling like 6 or 7 stress level. In this graph, we are stuck the stress level in a cumulative frequency, And the line between them are the distribution of the stress level between the semester. So this graph shows that, and for overall, yes, stress level 6 and 7 are mostly happen to occur in all semester, which is, we can see that the highest and with all colors, which is most usually occur in the students. And as we can see, we have pink color in different stress level, which is semester 4 has the, as I said before, various stress level for the students. So for the conclusion, Ben will explain.
From two analyses that we taken, we can conclude that although the students' stress levels remain consistent across semester, adopting a balanced approach that includes regular exercise and effective study habits can help in managing stress and improving academic performance. Yes, that is all for. So
Thank
we
you for
thank you for your attention and see you again next class.